Miscellaneous exercise on vectors. Question number 1. Write down a unit vector in xy plane, making an angle of 30 degree with the positive direction of x-axis. So let's draw xy plane first. So suppose this is y-axis. Suppose this is x-axis and this is z-axis. So we take a point P here. This is x-axis, this is y-axis, this is z-axis, and here making an angle of 30 degree with the positive direction of x-axis. So we take this angle as 30 degree. Now, since we are considering xy plane, so if we consider it in a general way, suppose this is x-axis, this is y-axis, then this is a line. And if this angle is 30 degree, then this angle must be 60 degree. So here z-axis will be perpendicular to both these axes. So this line will make 90 degree angle with the z-axis, and with other two axes 30 degree and 60 degree respectively. So we can write vector OP as cos 30 degree I cap plus cos 60 degree j cap plus cos 90 degree k cap. Here, in terms of direction cosine, these values are written. So now here, if there is doubt, so it can be understood that here this will be sine 30 degree perpendicular component, because if this angle is 30 degree, so here if we write it like this, component will be cos 30 degree and this component will be sine 30 degree, and sine 30 degree is same as cos 60 degree. So second point is written in terms of cosine, that is why instead of sine 30 degree cos 60 degree is used. So it will become root 3 by 2 I cap plus 1 by 2 j cap plus 0 times k cap. And if we want to find out the magnitude of OP, so that will be equal to 3 by 4 plus 1 by 4, which will give 1. So here, so unit vector OP will be same. So this thing root 3 I cap plus 1 j cap plus 0 k cap divided by 2, or we can write this as it is because its magnitude is 1. Now, second question is find the scalar components and magnitude of the vector joining the point this and this. So suppose we want to find out PQ vector, so we find the difference of the two, x2 minus x1 times I cap plus y2 minus y1 times j cap plus z2 minus z1 times k cap. So this will be required vector, and this and this will be scalar components. And suppose we want to find out its length, so we can apply formula x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Let's go to next question. A girl moves 4 kilometers west. So let's draw the directions here. Now suppose girl starts from O and she moves 4 kilometer. This will be west, this will be east, this is north, and this is south. So starting from here, she reaches to point A. Suppose OA equal to 4 kilometer. Then she walks 3 kilometer in a direction 30-degree east of north. 30-degree east of north. So we can just draw a line so that it may be clear. Now 30-degree east of north. So in this direction. So 30-degree east of north can be drawn like this. Let's try little thick. Suppose like this. Let's increase the angle by, this is 30-degree. Now, so this angle will be 60-degree. She walks 3 kilometer in the direction 30-degree east of north and stops. So final position is at B. Now determine the girl's displacement from her initial point of departure. Initial point of departure is O. So we have to find out this distance OB. So this angle 30, it means this will be 60-degree. So to find OB, we can write it, the displacement in form of vector. So OA will be equal to, if this is x-axis, this is I cap, this will be minus I cap, this will be j cap, this will be minus j cap. Let's consider the motion. So from O to A, it will be 4 minus I cap or minus 4 I cap, and then AB. So AB will be equal to, this is 3 kilometer, AB equal to given as 3 kilometer. So we take component, cos theta component, then 3 cos 60-degree I cap, and then perpendicular component 3 sine 60-degree j cap. So vector OB will be sum of these two vectors OA plus AB. So if we put these values, minus 4 I cap plus 3 cos 60-degree I cap plus 3 sine 60-degree j cap. So we put the values, so minus 4 I cap plus 3 into 1 by 2 j cap plus 3 into root 3 by 2 j cap. This is 3 cos, this is not j cap, this is I cap. Now, so if we simplify, it will become minus 5 by 2 I cap plus 3 root 3 by 2 j cap. So magnitude of OB can be found by putting values. So 25 by 4 plus 9 into 3 divided by 4. So this will come out to be root 30. Let's go to next question. Question number 4. If A vector equal to vector B plus vector C, then is it true that magnitude of vector A equal to magnitude of vector B plus magnitude of vector C? So if we write it in this way, vector A minus vector B minus vector C equal to 0. So just draw the triangle. Here, this triangle. Suppose this is vector A and this is vector B and this is vector C. So situation will be, we know that if all vectors are directed along the path shown, in that case sum will be 0. So Actually, A plus B plus C must be 0 if they are directed like this. So here, if we move in this direction, so if we take vector A positive, then C will be negative, B will be negative. So this is shown here. Now, here, these vectors represent the sides of triangle, and sum of any two sides must be greater than the third side. But here it is given that one side is equal to sum of other two, and that is not possible in case of triangle. Now, find the value of x for which this is a unit vector. So x times I cap plus j cap plus k cap is unit vector. It means modulus of this must be 1. So x times modulus of I j k will give 1 plus 1 plus 1 equal to 1, or x equal to 1 upon root 3. Now, next question is, find a vector of magnitude 5 units and parallel to the resultant of the vectors A and B. So here we can assume suppose vector C, which is parallel to the resultant of these two. So resultant means sum of the two here. So vector A plus vector B. So it will become 3i plus j plus 0k. Now, if we find its magnitude, so magnitude of vector C will be equal to 9 plus 1, that is root 10. Now we find a unit vector in the direction of vector C. So C cap will be vector C divided by modulus C. So this will be 3i plus j divided by root 10. Now required vector has magnitude 5 units. So let required vector is vector R will be 5 times C cap. So 5 times, so 5 by root 10 times 3i cap plus j cap. This can be further simplified by multiplying 5 root 10 divided by 10. 3i plus j. So it will become 10 root divided by 2, 3i cap plus j cap. Let's go to next question. If vector A equal to I plus j plus k, vector B equal to 2i minus j plus 3k, and vector C equal to I minus 2j plus k, then find a unit vector parallel to this. So let's evaluate 2a. So I plus j plus k minus b, that is 2i minus j plus 3k plus 3c, I minus 2j plus k. Suppose this is vector D. So 2i minus 2i, 2i minus 2i plus 3i plus 2j plus j minus 6j plus 2k minus 3k plus 3k. So this will give 3i and minus 3j plus 2k. So this is required vector, but here unit vector. So we have to find its magnitude also. So vector D will be equal to, modulus of vector D will be 9 plus 9 plus 4. That is root 22. So unit vector D cap will be vector D divided by modulus D. So vector D is 3i minus 3j plus 2k divided by root 22. This is required answer. Thank you for watching.